Hello everyone, today we're going to be going through how to solve quadratics. So we'll look at the first method, which is factorization. So factorization is probably the simplest way to solve them, and it involves finding two numbers that add together to make 5 and that times together to make 6, and they're the two factors for x. So for this one, this example, we'd have x plus 2, x plus 3, okay, because 2 times 3 is 6 and 2 plus 3 is 5. And then if we were to solve that, we have to set both of these equal to 0. So x plus 2 equals 0, x equals negative 2. X plus 3 equals 0, x equals negative 3. So the two solutions for this example is x equals negative 2 and x equals negative 3. This time we have a number in front of the x squared, so coefficient in front of the a term. Now to solve this one, it's a little bit of an extra step. So do 6 times 4 to start off with, multiply the two outside numbers, we'll just write that over here, it's 24. Now I need two numbers that multiply to make 24 and that add to make 10. So what are those two numbers? We have 4 and 6. 4 plus 6 is 10, 4 times 6 is 24. So we're going to write the next step here, and this next step is called splitting the middle term. Okay, now we factorize each of these halves, take out the highest common factor, 6x times x plus 1, and then on the right here it is 4 times x plus 1. So that's what it becomes, and then we can group these outside terms, 6x plus 4, and then x plus 1, and then we set both of these equal to 0 again, and then we solve for x. So we get x is equal to negative 4 over 6, and this one, x is equal to negative 1. So there are two solutions for x. Another way you can solve quadratics is by using the quadratic formula. Now you can use the quadratic formula to find the roots for any quadratic, but it usually takes a bit longer. So it's usually a last resort thing when you're solving quadratics. Now if we remember the general form of a quadratic, ax squared plus bx plus c. So we put the a, b, and c term into the formula here, and then it's just about simplifying down until you have two solutions for x. It takes a bit longer, but you will always get the correct answer if you use the quadratic formula. We're going to be talking about completing the square. It's another way to solve quadratics. So completing the square is still factorizing, but it's a specific way to factorize. So we're looking at, we have to half this middle term and square it. So that's the first step. So half of 6 is 3. 3 times 3 is 9. So we go x plus x squared plus 6x. And then we have that 9. So we're going to do plus 9 here. I'm going to bring that 5 down here. So plus 9 plus 5. And we have to minus the 9 over here. Okay? So we'll do that. We do the minus the 9 at the end. And this is still all equal to 0. So now we can see that we have a quadratic here. All right, this is a perfect square. So we have x squared plus 6x plus 9. We can factorize that into x plus 3 squared. And then we can take these two and combine them. So we have positive 5 minus 9 will give us negative 4. And this is still equal to 0. Now, the square root of negative 4, you can't really do it. Well, let's just look at negative 4 by itself. Negative 4, if we try to square root this, you can't really square root a negative number. But we know that -2 times by +2 will give us -4. So we have -2 and -4 are the two, -2 and +2 are the things that make up -4. So we can put that into the formula up here. So we keep the x plus 3, but then we put that -2, and then we do the other x plus 3 and put the positive 2 there is equal to 0. Okay, so we have a -2 and a +2. If we times them together, we will get this -4. And then once we do that, we then set both equal to 0. So x plus 3 minus 2 is equal to 0. X plus 3 plus 2 is equal to 0. And then we can just solve for x. So what do we have? X is equal to 3 minus 2 is 1. Move it across to the other side. X is equal to -1. 3 plus 2 is 5. Move it across. X is equal to -5. So that's our two solutions for x there when we complete the square. We'll go through one more method as well. All right, if you're using technology to solve quadratics, you just need to graph the function and then see where it intercepts with the x-axis. So if you have a function and you graph it, the solutions for the quadratic are the points where it crosses the x-axis here and here. So they would be the solutions. You wouldn't have to actually solve it algebraically if you were using technology.